Find dy by dx if y is equal to tan x upon x. Now here we will be applying the quotient rule to obtain the derivative. So differentiating with respect to x, we get dy by dx is equal to x times derivative of tan x minus tan x into derivative of x divided by x square. Further, we get x times, now derivative of tan x is sec²x minus tan x into derivative of x is 1 divided by x square. So finally the answer is x times sec²x minus tan x into 1 is tan x divided by x square. So this is the value for dy by dx. Find dy by dx if y is equal to cotx upon 1 plus x square. Now here again we will be applying the quotient rule to obtain the derivative. So differentiating with respect to x, we get dy by dx is equal to, we start with the denominator, so we have 1 plus x square into derivative of cotx minus cotx into derivative of 1 plus x square divided by 1 plus x square the whole square. Now further we obtain 1 plus x square times, now derivative of cotx is minus cosec²x minus cotx into, now here we apply the addition rule, derivative of 1 is 0 and derivative of x square is 2x. So cotx into 2x, the whole thing divided by 1 plus x square the whole square. Now we just rearrange the terms, taking this negative sign ahead over here. So we have minus of 1 plus x square into cosec²x, and just rearranging these two terms. So we have minus 2x times cotx divided by 1 plus x square the whole square. So this is the value for dy by dx. Find dy by dx if y is equal to sin x upon 1 plus x. So we will be applying the quotient rule to obtain dy by dx. So differentiating with respect to x, we get dy by dx is equal to, the first term will be 1 plus x into derivative of sin x minus sin x into derivative of 1 plus x divided by 1 plus x the whole square. Further, we get 1 plus x into derivative of sin x is cos x minus sin x into, now applying the addition rule, so we have derivative of 1, that is 0, and derivative of x is 1. So sin x into 1 divided by 1 plus x the whole square. So finally we have 1 plus x into cos x minus, now sin x into 1, so that is sin x divided by 1 plus x the whole square. So this is the value for dy by dx. Find dy by dx if y is equal to x raised to 4 into tan x minus x cube into sec x. So we differentiate with respect to x, and we have dy by dx is equal to derivative of x raised to 4 into tan x minus x cube into sec x. Now first we apply the subtraction rule for differentiation. So we obtain derivative of x raised to 4 into tan x minus derivative of x cube into sec x. And now if we observe, we have to apply the product rule on this term as well as this term. So we have to apply the product rule twice. So applying the product rule on the first term over here, so we have x raised to 4 into derivative of tan x plus tan x into derivative of x raised to 4 minus, now here again we apply the product rule. So we have x cube into derivative of sec x plus sec x into derivative of x cube. And now we get, now derivative of tan x is sec²x. So we have x raised to 4 into sec²x plus tan x into derivative of x raised to 4 is 4x cube minus, and the second bracket we have x cube into derivative of sec x is sec x into tan x plus sec x into, now derivative of x cube is 3x square. Now in these two terms we could take x cube as the common factor. See, here we could take x cube as the common factor, and here also x cube as the common factor. So taking x cube as the common factor in the first bracket, we have x cube into, so here we will be left with x into sec²x, and here we will be left with 4 times tan x, so plus 4 times tan x. Now in the second bracket we could take x square as the common factor and sec x also as the common factor. So this could be written as x square into sec x into, the remaining terms would be x into tan x plus, now sec x we have already taken it common, x square is also common, so we are left with 3. So x tan x plus 3. So this is the value for dy by dx. Find dy by dx if y is equal to 3x minus 5 into cotx minus 4x into sec x. So differentiating with respect to x, we have dy by dx is equal to d by dx of 3x minus 5 into cot x minus 4x into sec x. Now firstly we apply the subtraction rule for differentiation. So we just separate out these two terms. So we get derivative of 3x minus 5 into cot x minus, now since 4 is the coefficient, so we can just keep it outside the derivative. So 4 times derivative of x into sec x. And now we apply the product rule twice, that is in the first term and the second term. So let us apply the product rule on this term. So we get 3x minus 5 into derivative of cot x plus cot x into derivative of 3x minus 5 minus 4 times. Here again we apply the product rule. So we have x into derivative of sec x plus sec x into derivative of x. Now further we get, now 3x minus 5, this term remains as it is, into derivative of cot x is minus cosec square x plus cot x into, now derivative of these two terms over here, 3 is the coefficient and derivative of x is 1. So 3 times 1, that gives us 3. 5 is a constant, so its derivative value is 0. So we close the bracket. Minus 4 times x into derivative of sec x is sec x into tan x plus sec x into derivative of x is 1. And we just simplify the terms over here. We just rearrange these two terms. So we have minus 3x minus 5 into cosec square x, again rearranging these two terms, plus 3 times cot x minus, now here we could take sec x as the common factor, so we have 4 times sec x into, within brackets we have x into tan x plus 1. So this is the value for dy by dx.